What if I told you that you're living through one of the most catastrophic events in Earth's 4.6 billion year history? Right now, as you're watching this video, species are vanishing at a rate that rivals the most devastating disasters our planet has ever witnessed. But here's the twist that'll keep you up at night. Unlike every other mass extinction in Earth's past, this one has a face, and that face is staring back at you in the mirror. Before we dive into the apocalyptic nightmare that is mass extinction, let me paint you a picture of just how brutal these events really are. Imagine waking up tomorrow and 90% of everything alive on Earth is just gone. Not hiding, not hibernating, not relocated to another planet. Dead, extinct, forever. That's not science fiction. That's the reality of what scientists call the Great Dying that happened 252 million years ago. And it's just one of 5 catastrophic extinction events that have reset life on Earth. But here's what's absolutely mind-bending. Life found a way to bounce back every single time until now. Because the Sixth Mass Extinction, the one happening right under our noses, might be different. It might be the one that breaks the cycle forever. I'm about to take you on a journey through Earth's most devastating moments, where we'll uncover the cosmic assassins, volcanic hellscapes, and climate catastrophes that wiped out entire worlds of creatures. We'll discover how a single asteroid turned the mighty dinosaurs into museum displays, how massive volcanic eruptions created toxic oceans that killed 96% of marine life, and why scientists are now pointing their fingers directly at us as the architects of destruction number 6. But this isn't just a story about death and devastation. It's about resilience, adaptation, and the incredible tenacity of life itself. Because every mass extinction that tried to end the story of life on Earth actually wrote a new chapter. The question is, will we be writing the final chapter, or will we find a way to turn the page once more? Get comfortable, because what I'm about to show you will fundamentally change how you see the world around you. Every bird flying outside your window, every tree in your yard, every insect buzzing around your head exists because their ancestors survived apocalypses so severe they make our worst disaster movies look like children's bedtime stories. Let's start with the most basic question. What exactly is a mass extinction? It's not just a bunch of animals dying off. That happens all the time. In fact, there's something called the background extinction rate, where about 10% of species naturally go extinct every million years. That's just normal. Evolution's way of making room for new players on the biological stage. But a mass extinction? That's when the normal rules get thrown out the window. We're talking about losing 75% or more of all species on Earth in what geologists call a blink of an eye. And when geologists say blink of an eye, they mean anywhere from thousands to millions of years. Time works differently when you're dealing with a 4.6 billion-year-old planet. Now, here's where it gets really interesting. Scientists have identified what they call the Big 5 mass extinctions over the past 540 million years. 5 times when life on Earth came dangerously close to hitting the reset button permanently. And each one has a story that reads like the most intense thriller you've ever experienced. The first mass extinction happened 443 million years ago during something called the Ordovician Silurian extinction. Picture this. Earth was a completely alien world. The continents were clustered together in weird configurations. There was no life on land except maybe some primitive plants, and the oceans were absolutely teeming with bizarre creatures that looked like they came from another planet. These weren't cute little fish swimming around coral reefs. We're talking about massive sea scorpions the size of crocodiles, nautilus-like creatures with shells bigger than truck tires, and early vertebrates that were still figuring out this whole backbone thing. The ocean was their world, and it was thriving. Then the planet decided to throw them a curveball that wiped out 85% of all species. What happened? Ice. Lots and lots of ice. But not just any ice age, This was a global freeze so severe it locked up massive amounts of water in glaciers, causing sea levels to plummet by over 300 feet. Imagine the Atlantic Ocean dropping by the height of a 30-story building. All those shallow, warm seas where most marine life lived? Gone. Drained. The creatures that had evolved in tropical paradise suddenly found themselves in a frozen wasteland with nowhere to go. It's like someone took away the swimming pool while everyone was still in it. But the Ice Age was just the beginning. As if freezing wasn't bad enough, the planet then decided to rapidly warm up again. So now you've got species that managed to survive the freeze suddenly dealing with rising temperatures, changing ocean chemistry, and completely different environments. Talk about adding insult to injury. The really fascinating part about this first mass extinction is that it shows us something crucial about how these events work. It's rarely just one thing that kills everything off. It's a cascade of disasters, each one making the next one worse. The cooling triggered the glaciation, which dropped sea levels, which destroyed habitats, which made species more vulnerable to the warming that followed. This pattern, this domino effect of catastrophes, shows up again and again in every mass extinction. It's like the Earth has a particularly cruel way of making sure that when it decides to reset the biological clock, it does it thoroughly. What makes this even more mind-bending is that while 85% of species went extinct, the 15% that survived went on to diversify and fill all those empty ecological niches. Life didn't just recover, it exploded into new forms. The Ordovician extinction paved the way for fish to really take off, for early plants to colonize land, and for entirely new ecosystems to emerge. But before we get too optimistic about life's ability to bounce back, let's jump ahead to the second mass extinction, because this one shows us just how creative Earth can get when it comes to wiping out life. 374 million years ago, during what's called the late Devonian extinction, Earth was becoming recognizable in some ways. Fish were diversifying like crazy. The first forests were starting to appear on land, and early amphibians were taking their first tentative steps out of the water. It was a time of incredible innovation and expansion of life. Then something started going very wrong in the oceans. Over the course of about 20 million years, in several devastating pulses, roughly 75% of all species were wiped out. But this wasn't ice or fire or asteroids from space. This was death by suffocation on a planetary scale. The oceans started losing their oxygen, not all at once, but in waves of what scientists call anoxic events. Imagine the ocean as a giant lung that suddenly can't breathe. The oxygen levels plummeted, creating vast dead zones where nothing could survive. It was like someone was slowly turning off the life support system for the entire planet. Here's where it gets really twisted. The very success of life on land might have contributed to the extinction in the sea. Those new forests that were spreading across the continents, their deep roots were weathering rocks at an unprecedented rate, washing nutrients into the oceans. All those nutrients fed massive algae blooms that, when they died and decayed, sucked the oxygen right out of the water. So life on land was literally poisoning life in the sea. It's like an early preview of how biological success in one area can create catastrophic consequences in another. Sound familiar? We'll come back to that theme when we talk about what's happening today. But the Devonian extinction also had another player: volcanoes. Massive volcanic eruptions in what's now Siberia were pumping carbon dioxide and other gases into the atmosphere, contributing to climate change and ocean acidification. The combination of oxygen depletion, climate change, and ocean chemistry changes created a perfect storm of extinction. What's particularly haunting about the Devonian extinction is how it targeted specific groups. Reef-building creatures got absolutely devastated. Ancient relatives of modern corals, massive sea sponges, and the complex ecosystems they supported were nearly wiped out entirely. It's like someone went through the ocean with a checklist and specifically targeted anything that built homes for other creatures. This selective destruction shows us something important about mass extinctions. They don't affect all life equally. Some groups are more vulnerable than others, often because of where they live, what they eat, or how they reproduce. The creatures that build the foundations of ecosystems, the ones that create habitat for others, are often the first to go. And when the foundation crumbles, everything built on top of it comes crashing down. The recovery from the Devonian extinction took millions of years, and when it finally happened, the world that emerged was fundamentally different. New types of fish evolved to fill the empty seas. Different kinds of reef builders eventually appeared, and life continued its relentless march forward. But each extinction was teaching life a harsh lesson. Nothing lasts forever, and the only constant is change. The species that survived were the ones that could adapt, the ones that could roll with the punches that a dynamic planet kept throwing at them. Little did they know that the worst was yet to come. Because coming up next in our journey through Earth's most devastating moments is an extinction so severe, so absolutely catastrophic, that it earned the nickname that still gives paleontologists nightmares: the Great Dying. This wasn't just another reset button. This was nearly the end of the story entirely. 252 million years ago, Earth experienced something so catastrophic that it makes every other disaster in our planet's history look like a minor inconvenience. This was the Great Dying, the Permian Triassic Extinction, and it came closer to ending life on Earth permanently than any event before or since. Picture this nightmare scenario. You wake up and 96% of everything in the ocean is dead. Not sick, not struggling, not migrating to safer waters. Dead, gone forever. Then you look on land and 70% of all vertebrates have vanished. Even the insects, those indestructible survivors that seem to outlast everything, suffered their worst extinction event in Earth's history. This wasn't just a mass extinction. This was biological Armageddon. But here's what makes the Great Dying absolutely terrifying. It wasn't caused by some external cosmic accident like an asteroid impact. This was Earth turning on itself, becoming its own worst enemy through a process so violent and sustained that it nearly sterilized the planet. The villain in this story wasn't a space rock or gradual climate change. It was volcanoes. But not just any volcanoes. These were the Siberian Traps, a volcanic event so massive it defies comprehension. Imagine an area the size of Europe erupting continuously for over 1 million years. We're talking about lava flows that could bury the entire United States under hundreds of feet of molten rock. But the lava was just the opening act. The real killer was what came with it: an absolutely staggering amount of carbon dioxide, sulfur dioxide, and other toxic gases pumped into the atmosphere. The amount of CO2 released was so enormous that it triggered runaway global warming that made the planet nearly uninhabitable. Here's where the story gets really dark. As temperatures soared, something called positive feedback loops kicked in. These are nature's way of making bad situations exponentially worse. The warming atmosphere began melting vast deposits of methane hydrates frozen in the ocean floor and permafrost. Methane is a greenhouse gas that's 25 times more potent than carbon dioxide. So, as more methane entered the atmosphere, temperatures rose even faster, which melted more methane, which raised temperatures more, and on and on. It was like Earth had caught a fever that kept getting worse because the fever itself was causing the symptoms that made the fever worse. The planet was trapped in a death spiral of its own making. The oceans became toxic hellscapes. The warming water couldn't hold oxygen anymore, creating vast dead zones where nothing could breathe. But it gets worse. The volcanic emissions were also pumping hydrogen sulfide into the water, turning parts of the ocean into a poisonous soup that would kill anything that tried to live in it. Some scientists think the oceans became so toxic they were literally purple from all the sulfur bacteria. On land, the situation was just as apocalyptic. Temperatures in some regions soared to over 140 degrees Fahrenheit. That's hot enough to kill most plants and animals outright. The few forests that managed to survive the initial warming were then hit by acid rain so corrosive it could strip leaves from trees and poison the soil. But perhaps the most insidious killer was what scientists now call mega El Niño events. You know how El Niño can mess with weather patterns today? Imagine that, but cranked up to 11 and lasting for thousands of years. These weren't just weather disruptions, they were climate chaos that made normal seasonal patterns completely collapse. The mega El Niños created a feedback loop that was particularly brutal for plant life. As vegetation died off from the heat and toxic conditions, there were fewer plants to absorb CO2 from the atmosphere. With less CO2 being removed naturally, greenhouse gas concentrations kept rising, making conditions even worse for the remaining plants. It's like Earth's natural air conditioning system was breaking down at exactly the moment when it was needed most. The planet was essentially suffocating on its own exhaust fumes. What makes the Great Dying particularly terrifying is how long it lasted. This wasn't a quick catastrophe like an asteroid impact. The dying stretched on for hundreds of thousands of years, giving life just enough hope to recover slightly before the next wave of volcanic hell broke loose. It was death by 1,000 cuts, each one deeper than the last. The few species that managed to survive this planetary torture chamber were the ultimate evolutionary champions. They had to be incredibly adaptable, able to handle extreme heat, toxic air, poisonous water, and constantly changing conditions. These weren't just tough species, they were biological superheroes. Recovery from the Great Dying took an almost incomprehensible amount of time. For 15 to 30 million years after the extinction, Earth remained a biological wasteland with incredibly low diversity. Entire ecological roles sat empty for millions of years because nothing had evolved yet to fill them. When life finally did start to recover, it looked nothing like what came before. The Great Dying had wiped the slate so clean that evolution had to start almost from scratch, building new ecosystems from the handful of survivors that had endured the apocalypse. This is where our story takes a fascinating turn, because the recovery from the Great Dying set the stage for one of the most successful groups of animals in Earth's history. The extinction had cleared out the old guard, making room for a new dynasty to rise. A dynasty that would rule the planet for over 160 million years. The age of the dinosaurs was about to begin. But before we get to the rise of the terrible lizards, we need to talk about the extinction event that actually ended the Triassic period and kicked off the Jurassic. Because just as life was getting back on its feet after the Great Dying, Earth decided to throw another catastrophic curveball. 201.6 million years ago, the Triassic-Jurassic extinction hit like a geological sucker punch. 3/4 of all species suddenly vanished, and once again, massive volcanic eruptions were the primary suspect. But this time, the volcanic activity was literally tearing the supercontinent Pangaea apart. The Central Atlantic Magmatic Province wasn't just spewing lava, it was ripping apart what would become the Americas, Europe, and Africa. Imagine continents breaking up while simultaneously being flooded with millions of cubic miles of molten rock. The geological violence was unprecedented. But here's what makes the Triassic-Jurassic extinction particularly relevant to our story. Recent research suggests it wasn't primarily caused by global warming like previous extinctions. Instead, it was triggered by something called volcanic winter, when the massive eruptions blasted ash, sulfur, and debris into the atmosphere. They blocked out sunlight and caused global temperatures to plummet. It was like someone dimmed the lights on the entire planet. Plants couldn't photosynthesize, food webs collapsed, and species that had adapted to the gradually warming climate after the Great Dying suddenly found themselves in a frozen world. The volcanic winter was followed by extreme global warming as greenhouse gases built up in the atmosphere, creating a climate whiplash that most species simply couldn't survive. It was like going from a freezer to an oven in geological fast-forward. This extinction cleared the path for dinosaurs to become the dominant life form on the planet. The early dinosaurs that survived were small, adaptable creatures that could handle the climate chaos. Once the extinction was over, they exploded into an incredible diversity of forms, eventually producing the largest land animals that ever lived. For over 160 million years, dinosaurs ruled supreme. They evolved into every ecological niche imaginable. Massive, long-necked herbivores that were basically living skyscrapers, terrifying predators with teeth like railroad spikes, armored tanks that could shrug off attacks from the fiercest carnivores, and even flying reptiles with wingspans larger than small aircraft. The dinosaurs seemed unstoppable. They had survived multiple smaller extinction events, adapted to changing climates, and spread to every continent. They were the ultimate success story of evolution, a group so successful that it seemed like they might rule Earth forever. But success, as we've learned from every previous extinction, is temporary. And 66 million years ago, something was heading toward Earth that would end the age of dinosaurs in the most dramatic way possible. This wasn't going to be volcanoes or climate change or toxic oceans. This was going to be death from above, traveling at 20 miles per second, packing more energy than every nuclear weapon ever built combined. The asteroid that killed the dinosaurs was about to rewrite the rules of extinction forever. The space rock that ended the dinosaurs wasn't just big, it was catastrophically, mind-bendingly massive. We're talking about a chunk of asteroid roughly 6 to 9 miles across, hurtling through space at over 40,000 miles per hour. To put that in perspective, imagine a mountain-sized bullet traveling 60 times faster than a jetliner, carrying the kinetic energy of billions of atomic bombs. When this cosmic assassin slammed into what is now Mexico's Yucatan Peninsula 66 million years ago, it didn't just kill the dinosaurs. It rewrote the fundamental rules of how mass extinctions work. Every previous extinction had been a slow burn, taking hundreds of thousands or millions of years to unfold. This one happened in a matter of hours. The impact created a crater 112 miles across and temporarily punched a hole in the planet's crust so deep you could see the mantle glowing beneath. The explosion was so violent it launched millions of tons of vaporized rock into space, some of which didn't come back down to Earth for hours. When it did fall back, it heated the atmosphere so much that the entire surface of the planet became an oven. But here's what makes this extinction absolutely unique. We can trace it like a crime scene. There's a thin layer of clay found in rock formations all over the world that marks the exact moment the Cretaceous period ended and the Paleogene began. Scientists call it the KPG boundary, and it's loaded with iridium, a metal that's incredibly rare on Earth but common in asteroids. This discovery revolutionized how we think about extinction. Before 1980, scientists had all sorts of theories about what killed the dinosaurs. Maybe they got too big and couldn't adapt. Maybe mammals ate all their eggs. Maybe they were too stupid to survive changing climates. Then, physicist Luis Alvarez and his son Walter found that telltale iridium layer, and suddenly everyone realized that sometimes extinction comes from outside the Earth entirely. The asteroid impact triggered what scientists call an impact winter. Imagine the worst blizzard you've ever experienced. Except, instead of snow, it's pulverized rock, soot, and debris. And instead of lasting a few days, it lasts for months or even years. The sun disappeared behind a curtain of destruction, and photosynthesis ground to a halt across the entire planet. Plants died. Then the herbivores that ate the plants died. Then the carnivores that ate the herbivores died. It was ecological collapse in fast forward, a domino effect that rippled through every ecosystem on Earth. The massive dinosaurs that had ruled the planet for over 160 million years were suddenly too big, too specialized, and too dependent on ecosystems that had vanished overnight. But here's the plot twist that makes this story absolutely fascinating. Not everything died. Birds, which are actually dinosaurs, survived. Small mammals survived. Crocodiles, turtles, sharks, and many other groups made it through. The extinction wasn't random. It followed specific patterns that reveal something crucial about how life responds to catastrophic change. The survivors shared certain characteristics. They were generally smaller, which meant they needed less food. Many could eat a variety of things rather than being specialists. Some could burrow underground or live in water, which provided protection from the hellish conditions on the surface. Others had the ability to go dormant or survive on very little food for extended periods. The asteroid extinction was like a massive filter that sorted life into winners and losers based on very specific criteria. If you were big, specialized, or dependent on complex ecosystems, you were probably doomed. If you were small, adaptable, and could survive on scraps, you had a chance. What happened next changed everything. With the dinosaurs gone, mammals suddenly found themselves in a world full of empty ecological niches. For 160 million years, they had been small, mostly nocturnal creatures living in the shadows of the giant reptiles. Now, the shadows were gone, and mammals exploded into diversity. Within just a few million years after the asteroid impact, mammals evolved into forms that would have been impossible while dinosaurs dominated. Some became as large as rhinos. Others took to the trees, the skies, and eventually even returned to the oceans. This was evolution in overdrive, life rushing to fill every available space in the post-dinosaur world. The KPG extinction perfectly illustrates one of the most important principles of mass extinctions. They're not just about death, they're about opportunity. Every time Earth hits the reset button, it creates space for new evolutionary experiments. The mammals that inherited the post-dinosaur world eventually gave rise to whales, elephants, bats, primates, and thousands of other species that never could have existed in a dinosaur-dominated world. But perhaps the most significant mammal to emerge from the post-asteroid world was a small, tree-dwelling creature that appeared in the fossil record about 55 million years ago. It had grasping hands, forward-facing eyes, and a relatively large brain for its body size. This was one of the earliest primates, and its descendants would eventually walk upright, develop language, create art, build civilizations, and ultimately become the most powerful force of extinction the planet has ever seen. That's right, we're talking about us, humans, the species that would eventually become so successful that we'd trigger the Sixth Mass Extinction. But before we get to that sobering reality, we need to understand something crucial about the pattern we've been seeing throughout Earth's history. Each of the Big Five extinctions was caused by planetary-scale environmental changes that happened faster than most species could adapt. The Ordovician extinction was triggered by rapid cooling and warming. The Devonian extinction was caused by ocean, oxygen, depletion, and volcanic activity. The Permian extinction resulted from massive volcanism and runaway greenhouse effects. The Triassic extinction involved volcanic winter followed by extreme warming. And the Cretaceous extinction was caused by asteroid impact and its cascading effects. In every case, the extinctions were driven by changes to Earth's climate and chemistry that happened on timescales much faster than the normal pace of evolution. Species that had spent millions of years adapting to stable conditions suddenly found themselves in a world that was changing faster than they could keep up with. The survivors in each extinction weren't necessarily the strongest or the smartest. They were the most adaptable, the ones that could handle rapid environmental change, the generalists rather than the specialists. This pattern holds true across all 5 major extinctions, and it's teaching us something important about what makes species vulnerable to extinction. Here's where our story takes a deeply unsettling turn. Because as we've traced the history of these catastrophic events, we've been building toward a realization that should fundamentally change how you see the world around you. The Sixth Mass Extinction isn't coming. It's already here. And for the first time in Earth's 4.6 billion year history, a single species is causing it. That species is us. Right now, species are disappearing at a rate that's hundreds to thousands of times faster than the natural background extinction rate. We're losing biodiversity so quickly that scientists estimate we're eliminating species faster than we can even discover and catalog them. Many creatures are going extinct before we ever knew they existed. But here's what makes the current extinction event so different from all the others. It's not being caused by volcanoes, asteroids, climate shifts, or any other natural process. It's being caused by one species that has become so successful, so dominant, so capable of reshaping entire ecosystems that we've essentially become a geological force. Humans have transformed more of Earth's surface than any other species in the planet's history. We've changed the chemistry of the atmosphere and oceans. We've moved species around the globe, creating invasive populations that disrupt ecosystems that took millions of years to evolve. We've fragmented habitats, polluted environments, overharvested resources, and altered the climate at a pace that rivals the fastest natural changes in the geological record. We are simultaneously the asteroid, the volcano, the toxic ocean, and the climate chaos all rolled into one. We've become the most powerful extinction force the planet has ever produced, and unlike previous mass extinctions, this one comes with something unprecedented: awareness. We know what we're doing. We can measure it, study it, predict it, and potentially stop it. That makes us either the most dangerous species in Earth's history, or potentially its greatest hope for breaking the cycle of mass extinction. The question that will define our species and possibly the future of life on Earth is this: will we be remembered as the cause of the sixth mass extinction, or as the first species in the planet's history to recognize an extinction crisis and actually do something to stop it? The answer to that question is being written right now, in real time, through every decision we make as a species. And to understand just how critical this moment is, we need to look at exactly how we became an extinction force so powerful that we're literally reshaping the tree of life itself. It didn't happen overnight. For most of human history, we were just another species trying to survive in a world full of bigger, stronger, faster predators. Our ancestors lived in small groups, used simple tools, and had about as much impact on global ecosystems as any other medium-sized mammal. We were part of the natural order, not its master. But then something changed. Around 10,000 years ago, we figured out agriculture. Suddenly, instead of hunting and gathering whatever nature provided, we could control our food supply. We could support larger populations, build permanent settlements, and start accumulating resources. This wasn't just a technological breakthrough. It was the moment humans began to separate themselves from the natural world. Agriculture led to civilization. Civilization led to technology. And technology led to something unprecedented in Earth's history: a single species that could consciously modify entire landscapes to suit its needs. We went from being subject to natural selection to being the selector ourselves. The pace of change accelerated dramatically during what we call the Industrial Revolution, starting around 250 years ago. This is when humans really started flexing our planet-altering muscles. We began burning fossil fuels on a massive scale, pumping carbon dioxide into the atmosphere faster than it had been released since those catastrophic volcanic events that caused previous mass extinctions. We developed industrial-scale fishing that could empty entire ocean regions of life. We created chemical pesticides and fertilizers that could poison ecosystems hundreds of miles away from where they were applied. We built cities, roads, and farms that fragmented natural habitats into isolated islands where species couldn't maintain viable populations. But, perhaps most importantly, we developed the ability to move around the globe and take other species with us, intentionally or accidentally. This might sound harmless, but it's actually one of the most devastating things any species has ever done to Earth's biodiversity. For millions of years, evolution has been creating unique species on different continents and islands, each adapted to their specific local conditions. Australia developed marsupials. Madagascar had lemurs. Islands evolved flightless birds. And isolated ecosystems created incredible diversity through what scientists call adaptive radiation. Then, humans showed up and started mixing everything together. We brought cats to islands where birds had never seen a mammalian predator. We introduced rats to places where small, ground-dwelling animals had no defenses. We moved diseases between continents, wiping out species that had no immunity to foreign pathogens. We essentially took millions of years of carefully separated evolutionary experiments and threw them all together in a blender. The results have been catastrophic for native species around the world. Island birds that had lost the ability to fly because there were no land predators suddenly found themselves face to face with introduced cats and rats. Native plants that had evolved without grazing animals were suddenly being eaten by introduced livestock. This biological mixing, combined with habitat destruction, pollution, overharvesting, and climate change, created what scientists call the evil quartet of human-caused extinction drivers. Unlike the single catastrophic events that caused previous mass extinctions, we're hitting life on Earth with multiple devastating blows simultaneously. The scale of what we've accomplished as an extinction force is honestly breathtaking when you step back and look at the numbers. Since the year 1500, we've driven to extinction roughly 30% of all species that were alive at that time. That's not 30% of species in one region or one type of ecosystem. That's 30% of everything, everywhere, across the entire planet. We've eliminated 68% of vertebrate populations since 1970. Think about that for a moment. In just 50 years, we've reduced wildlife populations by more than 2/3. We're essentially watching the biological richness of our planet drain away in real time. The ocean tells an even more sobering story. We've removed 90% of large predatory fish from the seas. Imagine if 90% of all the lions, tigers, bears, and wolves on land just disappeared. That's what we've done to sharks, tuna, marlin, and other ocean predators. We've created ecological holes so large that entire marine food webs are collapsing. Coral reefs, often called the rainforests of the sea because they support such incredible diversity, are experiencing their own mass extinction event. Rising ocean temperatures caused by climate change are triggering massive bleaching events that kill entire reef systems. We've lost about 30% of all coral reefs, and current projections suggest we could lose most of the rest within the next few decades. But here's what makes our extinction crisis particularly insidious. It's not just about the species we're killing directly. We're also eliminating the conditions that allow new species to evolve. Evolution requires time, stable environments, and isolated populations where new adaptations can develop. We're destroying all three. Habitat fragmentation means populations are too small and too isolated to maintain genetic diversity. Rapid environmental change means species don't have time to adapt before conditions change again. And our global transportation network means populations that might have been isolated long enough to evolve into new species are constantly being mixed with individuals from other regions. We're not just causing a mass extinction, we're potentially ending the process of speciation itself in many groups. We're turning evolution off. The comparison to previous mass extinctions becomes even more chilling when you look at the timescales involved. The Great Dying took hundreds of thousands of years to eliminate 96% of marine species. We're on track to achieve similar levels of species loss in just a few centuries. We're conducting a mass extinction in fast forward. And unlike asteroid impacts or volcanic eruptions, our extinction crisis isn't a single catastrophic event followed by recovery. It's a sustained assault that keeps getting more intense as our population grows, our consumption increases, and our technology becomes more powerful. We've become what scientists call a hyper-keystone species, a term that barely captures the magnitude of our impact. Keystone species are ones whose effects on ecosystems are disproportionately large compared to their abundance. Remove a keystone species, and entire ecosystems can collapse. But humans aren't just a keystone species. We're a hyper-keystone species whose impacts ripple through every ecosystem on the planet. We affect species we've never seen, in places we've never been, through chains of cause and effect that span the globe. The pesticides we spray in agricultural fields end up in Arctic ice. The carbon dioxide we emit from burning fossil fuels is acidifying oceans on the other side of the world. The demand for products in wealthy countries drives deforestation in tropical nations. We've created a globally interconnected web of destruction that touches every corner of the planet. But here's where the story takes a potentially hopeful turn, because we're also the first species in Earth's history that can actually understand what we're doing and potentially change course. Every previous mass extinction was caused by blind natural forces. Volcanoes don't feel guilt about releasing toxic gases. Asteroids don't have moral qualms about slamming into planets. We do. We can study our impact, measure our effects, and make conscious decisions about how we interact with the rest of life on Earth. We have something that no extinction-causing force in Earth's history has ever had: the ability to choose differently. This consciousness, this awareness of our role as an extinction force, is both terrifying and potentially liberating. It means the responsibility for the Sixth Mass Extinction rests entirely on our shoulders. But it also means we have the power to do something about it. The question is whether we'll use that power before it's too late. Because while we've been incredibly successful at causing extinctions, we're still learning whether we can be equally successful at preventing them. Some scientists argue we've already crossed the point of no return, that we've triggered cascading ecological collapses that will continue regardless of what we do now. Others believe we still have a narrow window of opportunity to prevent the worst outcomes, but only if we act with unprecedented speed and coordination. The challenge we face is unlike anything our species has ever attempted. We need to simultaneously feed, house, and provide energy for billions of people while dramatically reducing our impact on the natural world. We need to develop technologies that work with natural systems rather than against them. We need to change economic systems that prioritize short-term growth over long-term sustainability. Most importantly, we need to fundamentally shift how we see ourselves in relation to the rest of life on Earth. Instead of viewing nature as a collection of resources to be exploited, we need to recognize that we're part of an interconnected web where our survival depends on the health of the whole system. This isn't just an environmental challenge, it's an existential one. Because if we fail to control our role as an extinction force, we're not just destroying other species, we're potentially destroying the conditions that allow human civilization to exist. The ecosystems we depend on for clean air, fresh water, fertile soil, and climate stability are the same ones we're systematically dismantling through our extinction crisis. We're essentially sawing off the branch we're sitting on, and doing it faster than any species in Earth's history has ever managed to destroy its own life support system. But here's where the story gets really complex. Because unlike those cosmic asteroids or volcanic hellscapes that caused previous extinctions, we're not just destroyers, we're also creators. We're the first species that can consciously design solutions to the problems we've created. We can engineer technologies that work with nature instead of against it. We can restore ecosystems we've damaged. We can bring species back from the brink of extinction. The question is whether our creative abilities can outpace our destructive ones. And that's where the current mass extinction becomes unlike anything in Earth's history. Because for the first time ever, the outcome isn't predetermined by blind natural forces. It's a choice. Right now, there are scientists working around the clock to understand which species are most at risk and how to protect them. There are conservationists developing new strategies to restore damaged ecosystems. There are engineers creating technologies that could revolutionize how we produce energy, grow food, and manufacture goods without destroying the natural world. Some of these solutions sound like science fiction, but are already being tested in the real world. Scientists are using genetic techniques to help coral reefs adapt to warmer waters. They're developing vertical farms that can produce food with 95% less water and no pesticides. They're creating materials that could replace plastics and break down harmlessly in the environment. We're even exploring technologies that could potentially reverse some of the damage we've already done. Carbon capture systems that could pull greenhouse gases out of the atmosphere. Rewilding projects that could restore entire ecosystems. De-extinction techniques that might bring back species we've already lost. But here's what makes our situation both more hopeful and more terrifying than any previous extinction crisis. Success or failure depends entirely on us making the right choices and making them fast enough to matter. The speed of our decision-making needs to match the speed of our destruction. We're operating on geological timescales of change, but with human timescales of response. It's like trying to steer a spacecraft while traveling at light speed. Every second of delay makes the problem exponentially harder to solve. The most sobering part of studying Earth's previous mass extinctions is realizing that life always found a way to recover, but it took millions of years. And the world that emerged was always fundamentally different from what came before. After the Great Dying, it took 30 million years for ecosystems to fully recover their complexity. After the asteroid that killed the dinosaurs, it took 10 million years for mammalian diversity to fully explode into new forms. We don't have millions of years to wait for natural recovery. Human civilization has existed for only about 10,000 years. Our entire recorded history spans less time than it took for ecosystems to recover from just one of the previous mass extinctions. This means that if we push the sixth extinction to its full conclusion, we won't be around to see the recovery. The new world that eventually emerges from the ecological rubble we're creating will be shaped by whatever species manage to survive our onslaught, and there's no guarantee that world will be capable of supporting human civilization. But there's another possibility that makes our extinction crisis unique in Earth's history. What if we could be the first species to trigger a mass extinction and then consciously guide the recovery? What if, instead of just being an extinction force, we could become a force for evolutionary innovation and ecological restoration? This isn't just wishful thinking. There are already examples of humans acting as positive evolutionary forces. We've created new habitats that some species have adapted to thrive in. We've facilitated the recovery of species that were on the brink of extinction. We've even helped evolution along by protecting genetic diversity and creating conditions where new adaptations can emerge. The California condor was down to just 27 individuals in the wild. Through intensive conservation efforts, there are now over 500. The Arabian oryx was actually extinct in the wild and only survived in captivity, but has now been successfully reintroduced to its natural habitat. These aren't just conservation success stories. They're proof that we can reverse our role as an extinction force. But scaling up from individual species to entire ecosystems, from local successes to global solutions, requires something our species has never attempted before: coordinated action on a planetary scale. With the urgency that mass extinction timelines demand, we need to think like a geological force, because that's what we've become. Our decisions need to account for their impacts not just on human society, but on the entire web of life that makes our planet habitable. We need to start thinking in terms of deep time while acting with the speed of an emergency response. The fossil record shows us that every previous mass extinction was followed by an explosion of evolutionary innovation. The survivors didn't just recover, they diversified into forms that had never existed before. Each extinction opened up ecological opportunities that led to entirely new kinds of life. The mammals that inherited the post-dinosaur world became whales, elephants, bats, and primates. The survivors of the Great Dying eventually gave rise to dinosaurs, marine reptiles, and the first flowering plants. Every mass extinction was simultaneously an ending and a beginning. If we're going to be the architects of the Sixth Mass Extinction, we also have the opportunity to be the architects of what comes next. We could consciously shape the recovery in ways that create a more resilient, more diverse, more stable biosphere than has ever existed on Earth. But that would require us to see ourselves not as separate from nature, but as nature's newest evolutionary experiment. An experiment in conscious evolution, where intelligence and awareness become tools for enhancing life rather than destroying it. The challenge is enormous. We need to feed, house, and provide energy for billions of people while simultaneously restoring the ecosystems we've damaged. We need to develop economic systems that value biodiversity as much as they value profit. We need to create technologies that enhance natural processes rather than replacing them. Most importantly, we need to change the story we tell ourselves about what it means to be human. For too long, we've seen ourselves as conquerors of nature, as a species that succeeded by dominating and controlling the natural world. But the mass extinction we're causing is showing us that this story leads to a dead end. We need a new story, one where human success is measured not by how much of the natural world we can control, but by how well we can integrate ourselves into the web of life that sustains us. We need to see ourselves as participants in the ongoing evolutionary experiment, not its masters. The fossil record of previous mass extinctions teaches us that life is incredibly resilient, but it also teaches us that individual species are not. Every creature that has ever lived on Earth has eventually gone extinct. That's not a pessimistic view, it's just reality. The question isn't whether humans will eventually go extinct. It's whether we'll go extinct as part of a mass extinction we caused, or whether we'll find a way to gracefully integrate ourselves into the ongoing story of life on Earth. Right now, we're writing the most important chapter in that story. The decisions we make in the next few decades will determine not just the fate of our own species, but the trajectory of evolution itself for millions of years to come. We could be remembered as the species that caused the Sixth Mass Extinction and then went extinct ourselves, leaving behind a planet struggling to recover from our destructive legacy. Or we could be remembered as the species that recognized its power to destroy, chose instead to create, and ushered in a new kind of relationship between intelligence and the natural world. The choice is ours, and it's being made right now, through every policy decision, every technological innovation, every shift in how we see ourselves in relation to the rest of life on Earth. But before we can make that choice intelligently, we need to understand exactly what we're up against. We need to look at the mechanisms driving the current extinction crisis, the speed at which it's accelerating, and the narrow window of opportunity we have left to change course. Because while the story of Earth's mass extinctions teaches us that life always finds a way to continue, it also teaches us that most individual species don't survive the transition. And right now, our species is conducting an experiment to see which category we'll end up in. The clock is ticking, and unlike the slow geological processes that drove previous extinctions, our extinction crisis is operating on human timescales. Every year we delay action, every month we spend debating rather than acting, makes the challenge exponentially more difficult. We're approaching what scientists call tipping points, thresholds beyond which changes become irreversible and self-reinforcing. Cross enough of these tipping points, and we could trigger cascading ecological collapses that continue regardless of what we do to try to stop them. The Amazon rainforest is approaching a tipping point where it could shift from being a carbon sink that helps stabilize climate to a carbon source that accelerates warming. Arctic ice sheets are approaching tipping points where their melting becomes unstoppable. Ocean currents that regulate global climate are showing signs of approaching collapse thresholds. Each of these tipping points represents a point of no return, where our choices stop mattering because we've triggered changes that will continue on their own momentum. It's like pushing a boulder down a hill. At first, you can still stop it, but once it gains enough momentum, it's going to roll to the bottom regardless of what you do. This is why the speed of our response matters so much. We're not just racing against extinction. We're racing against the moment when our ability to influence the outcome disappears entirely. We're trying to steer a planetary system that's gaining momentum toward outcomes we might not be able to survive. But the same intelligence that made us capable of causing a mass extinction also makes us capable of understanding these tipping points, predicting them, and potentially avoiding them. We have something no previous extinction-causing force has ever had: the ability to model complex systems, predict future outcomes, and adjust our behavior based on those predictions. The question is whether we'll use these capabilities quickly enough and effectively enough to matter. Because the window of opportunity for preventing the worst outcomes of the Sixth Mass Extinction is closing fast, and once it closes, the story of life on Earth will be written by forces beyond our control. The terrifying truth about where we stand right now is that we're not just approaching these tipping points, we're already beginning to cross some of them. And the scariest part? Most people have no idea it's happening because, unlike an asteroid screaming through the atmosphere or a volcano exploding in a spectacular display of destruction, the Sixth Mass Extinction is unfolding in slow motion, hidden in statistics and scientific papers that never make it to the evening news. Let me give you a reality check that'll make your stomach drop. Right now, as you're sitting there watching this video, somewhere on Earth a species just went extinct. Not in a dramatic Hollywood explosion, but quietly, unnoticed, as the last individual of some creature that took millions of years to evolve simply died without reproducing. This isn't hyperbole, it's math. We're losing species so fast that extinction events that should be front-page news happen multiple times every single day. But here's what makes our situation even more mind-bending than anything that's happened in Earth's previous 4.6 billion years. We're not just causing extinctions faster than any natural process in the planet's history. We're also documenting it in real time. We have satellites watching forests disappear, sensors monitoring ocean chemistry changes, and genetic databases tracking the collapse of biodiversity with a precision that would have been impossible just decades ago. We're essentially live-tweeting our own mass extinction event, and the data we're collecting is painting a picture so disturbing that many scientists are struggling with what researchers call ecological grief, the psychological trauma of watching the natural world collapse faster than they can study it. Consider what's happening to insects, the tiny creatures that most people barely notice, but that keep entire ecosystems functioning. In just the last few decades, we've lost over 75% of insect biomass in many regions. That means 3/4 of all the bugs that were buzzing around when your parents were kids are just gone, vanished. And with them went the pollination services, waste decomposition, and food web connections that keep natural systems running. This isn't just about fewer bees making honey or fewer butterflies in your garden. This is about the collapse of ecological processes that have been running continuously for hundreds of millions of years. When insects disappear, the birds that eat them disappear. When those birds disappear, the plants they pollinate and spread seeds for begin to disappear. When those plants disappear, the soil systems they supported begin to collapse. It's like watching a biological Jenga tower where we keep pulling out pieces until the whole structure becomes unstable. Except, unlike Jenga, When this tower falls, it doesn't just make a satisfying crash and then get rebuilt. When ecological systems collapse, they can stay collapsed for millions of years. The ocean tells an even more apocalyptic story. We're not just overfishing, we're fundamentally altering marine chemistry faster than it's changed since the Great Dying. The carbon dioxide we're pumping into the atmosphere isn't just warming the planet, it's making the oceans more acidic. And acid oceans dissolve the shells and skeletons that marine creatures need to survive. Imagine trying to build a house while someone keeps pouring acid on your building materials. That's what we're doing to every creature in the ocean that builds shells, creates coral reefs, or constructs the calcium carbonate structures that form the foundation of marine ecosystems. We're chemically dissolving the architecture of ocean life. The speed of this acidification is staggering. Ocean pH is dropping faster than it has in 300 million years. We're essentially conducting a chemistry experiment on the largest ecosystem on our planet, using the entire ocean as our laboratory, with no idea what the final results will be. But perhaps the most chilling aspect of our current extinction crisis is how it's accelerating. Each environmental problem we create makes the others worse, creating what scientists call synergistic effects, where the combined impact is greater than the sum of its parts. Climate change makes species more vulnerable to disease. Habitat fragmentation makes populations less able to adapt to climate change. Pollution weakens immune systems just when species need to be strongest to survive other stressors. We've created a perfect storm of extinction drivers that reinforce each other in a cascade of destruction that feeds on itself. It's like we've built a machine specifically designed to eliminate biodiversity, and then we keep making it more efficient. The parallels to previous mass extinctions are becoming impossible to ignore. The rate at which we're changing atmospheric chemistry rivals the volcanic events that caused the Great Dying. The speed of climate change we're causing matches the most rapid warming events in the geological record. The scale of habitat destruction we're orchestrating exceeds anything since the asteroid that ended the dinosaurs. But there's one crucial difference that makes our extinction event potentially more devastating than anything that's come before. We're attacking life from multiple directions simultaneously. Previous mass extinctions were caused by single catastrophic events or processes. The asteroid was just an asteroid. The volcanoes were just volcanoes. We're the asteroid, the volcano, the climate change, the toxic ocean, and the habitat destruction all rolled into one supremely destructive force. And we're doing it while the planet is already stressed by our presence. For the last 10,000 years, since we invented agriculture and started building civilizations, we've been steadily increasing our pressure on natural systems. We've cleared forests, diverted rivers, hunted species to extinction, and altered landscapes on every continent. The ecosystems we're now pushing toward collapse are already weakened by thousands of years of human pressure. It's like we've been slowly turning up the heat under a pot for millennia, and now we're suddenly cranking it to maximum while also adding poison to the water and shaking the pot violently. The creatures inside don't just have to deal with one catastrophic change. They have to deal with multiple catastrophic changes happening simultaneously to systems that were already under stress. This is why conservation biologists talk about our current moment as a perfect storm of extinction drivers. We've managed to combine the worst aspects of every previous mass extinction into a single, ongoing catastrophe that's happening at unprecedented speed. The psychological impact of recognizing this reality is profound. Scientists who dedicate their careers to studying biodiversity are watching their life's work disappear before their eyes. Marine biologists who spend decades studying coral reefs are witnessing those reefs bleach and die within a few years. Ornithologists who have tracked bird populations for their entire careers are documenting the collapse of species they've known since childhood. There's a term in psychology called solastalgia, the distress caused by environmental change in your home environment. It's the feeling you get when the landscape you grew up in becomes unrecognizable. When the sounds of nature you remember from childhood fall silent, when the places that gave you comfort and connection to the natural world are transformed into something alien and lifeless. Millions of people around the world are experiencing solastalgia as the Sixth Mass Extinction unfolds around them. The forests of their childhood are gone. The beaches where they used to find shells are now littered with plastic. The night sky they remember teeming with insects is now eerily quiet. The seasonal rhythms of wildlife behavior that mark the passage of time have become unpredictable or disappeared entirely. This psychological dimension of mass extinction is something that's never existed before. Previous extinctions happened to creatures that couldn't comprehend what was happening to them. They experienced the immediate effects of environmental change, but they couldn't grasp the larger pattern of collapse or anticipate what was coming next. We can. We have the cognitive capacity to understand that we're living through one of the most significant events in the history of life on Earth, and that knowledge carries a psychological weight that no species has ever had to bear. We're simultaneously the cause of the destruction, the witnesses to it, and potentially the only hope for stopping it. This creates a unique form of existential crisis. We're forced to confront our role as destroyers while also grappling with our responsibility as potential saviors. We have to live with the knowledge that every day we delay action, more species disappear forever, while also trying to maintain hope that we can still change course in time to prevent total ecological collapse. The weight of this responsibility is staggering when you really think about it. Every previous mass extinction was caused by forces beyond any species' control. No dinosaur could have deflected the asteroid. No marine creature could have stopped the volcanic eruptions that caused the Great Dying. But we have the power to stop the Sixth Mass Extinction, which means every species that goes extinct on our watch is, in some sense, a choice we made. That's a level of moral responsibility that no species in Earth's history has ever faced. We're not just trying to survive a mass extinction, we're trying to decide whether to cause one. And that decision is being made right now through millions of individual choices about how we live, what we consume, what we prioritize, and what kind of future we want to create. The fossil record shows us that life is incredibly resilient over geological timescales, but it also shows us that individual species are incredibly fragile during times of rapid environmental change. The question we face is simple but terrifying. Which category will we end up in? Will we be among the survivors who adapt and help guide the recovery? Or will we be among the casualties who couldn't change fast enough to keep up with the world we created? The answer depends on choices we're making right now, and the clock is ticking faster than most people realize. Because here's the thing about tipping points and cascading collapses. They don't announce themselves with sirens and flashing lights. They happen quietly, gradually, until suddenly they don't. Until suddenly the changes become irreversible and the systems we depend on begin failing in ways that cascade through our entire civilization. We're not just causing the Sixth Mass Extinction, we're potentially engineering our own inclusion in it. And unlike the dinosaurs, who never saw the asteroid coming, we can see exactly what's heading our way. The question is whether we'll use that knowledge to change course, or whether we'll keep accelerating toward a future that no species, including us, might be able to survive. The next part of our story isn't written in stone like the fossil record of previous extinctions. It's being written right now, in real time, through every choice we make about how to respond to the crisis we've created. And that makes this moment in Earth's history unlike anything that's ever happened before. For the first time in 4.6 billion years, the outcome of a mass extinction event is up for grabs. The ending isn't predetermined by asteroid trajectories or volcanic eruption cycles. It's being decided by us through our actions, our innovations, our willingness to change, and our ability to work together on a scale that matches the magnitude of the crisis we're facing. That's either the most terrifying responsibility any species has ever faced, or the greatest opportunity in the history of life on Earth? The outcome depends entirely on what we do next. So here we stand at the edge of our own making, staring into an abyss that reflects our faces back at us with perfect clarity. We've journeyed through 4.6 billion years of planetary catastrophe, witnessed volcanic hellscapes that turned oceans purple with poison, watched asteroids rewrite the rules of existence in a matter of hours, and traced the slow recovery of life from apocalypses so complete they nearly ended the story forever. But every extinction we've explored pales in comparison to the one we're conducting right now. Not because it's more geologically dramatic than the Great Dying or more instantly devastating than the asteroid that killed the dinosaurs, but because it's the first extinction in Earth's history where the cause can look itself in the mirror and choose to stop. The fossil record has taught us that mass extinctions aren't just endings, they're transformations. Every catastrophe that tried to silence life forever actually gave it new voices. The survivors didn't just endure. They exploded into forms that had never existed before, filling the empty world with innovations that previous eras couldn't have imagined. We have the opportunity to be part of that transformation, but only if we recognize what we've become and choose what we want to be. We've spent the last few centuries proving we can be the most destructive force in Earth's history. The question now is whether we can become its greatest creative force instead. The choice is being made right now, through every action we take and every day we delay. Unlike the dinosaurs staring up at their cosmic executioner, we can see what's coming. We can measure it, predict it, and change it. That makes us either Earth's greatest hope or its final disaster. What will your choice be?